Right now, there's a story being told about the future of artificial intelligence, a really seductive story. And it ticks off with a promise that, let's be honest, sounds way too good to be true. And this is the promise that intelligence itself is on a path to becoming as cheap, as accessible, and as abundant as electricity from a wall socket. Just a free utility powering this whole new world. I mean, it's a fantastic vision, but there's a huge problem with it. Because, nothing is ever truly free. Somewhere a meter is running. Somewhere there's a massive bill coming due. And that bill, it changes absolutely everything we think we know about the race for AI dominance. Okay, let's get right into this. The first illusion we really need to shatter is this idea that the $20 a month you might pay for some AI service has any connection to reality. It's a complete fiction. Now, what's so fascinating about this is the brutal economic truth it lays bare. Over on the left, you've got the healthy, predictable margins of traditional software. And on the right, well, that's the generative AI business. Those razor-thin margins, a lot of them actually negative, are being subsidized by billions in venture capital. This isn't just a sustainable business model, it's a land grab, and the cash is burning at a mind-blowing rate. So here's the crucial thing to grasp. Where is all that money going? I mean, we hear all the time about the massive cost of training these huge models, right? That's the CapEx, the giant one-time mountain you have to climb. But the real killer, the thing that's actually bleeding these companies dry, is the operating expense of running the model. We call that inference. And it's not a mountain. It's a perpetual rising ocean tide of costs that comes in with every single query. And this right here gets to the heart of the disconnect. Every single time you ask a question, generate an image, or write a line of code with an AI, you are triggering this cascade of incredibly expensive computation. That subscription fee is a fantasy. The compute cost is the unforgiving reality. So let's be crystal clear on what we're calling the villain here. Inference. It is not a one-time fee. It's the cost of every single token the model generates for you forever. It's the meter that is always, always running. This quote from an industry analysis just says it all. In this new world, efficiency isn't just some nice-to-have feature. It is the central strategic imperative. The entire game is shifting from building the biggest model to building the most efficient one. But here's the turn. This isn't just a business problem that you can solve with a better pricing model. Oh no, this is a physics problem. We are running headfirst into a fundamental physical barrier. I want you to think about today's AI accelerators, the GPUs. They are absolute monsters of computation. They can perform trillions upon trillions of calculations per second. They are just hungry for math. But all that computational power is totally useless if you can't feed the beast. And right now, these math monsters are being fed data through a ridiculously tiny straw. And that straw is called memory bandwidth. This is the memory wall. It's the true antagonist in the story of AI's future. The physical act of just shuttling data back and forth between the memory and the processor now costs far more in time and energy than doing the actual math. We've gotten so good at calculating that the logistics of simply moving the numbers has become the bottleneck. All right, let's make this tangible. When you're having a conversation with an AI, the model has to remember what you've already talked about to make any sense, right? This memory is stored in something called a KV cache. And here's the kicker. It lives in the most expensive, high-speed memory available. So as your conversation gets longer, that cache just explodes in size, eating up all those precious resources. That is the invisible memory tax that limits how many people can actually use the system at the same time. So the economics are broken and we're being constrained by the laws of physics. How does AI even survive? How does it scale? Well, you have to change the architecture of the system itself. The question becomes less about building bigger and bigger models and more about finding really clever ways to work around this fundamental physical law. You can't break the law, but maybe, just maybe, you can cheat it. And here is the arsenal for this rebellion. Now, these aren't just small tweaks, they are fundamentally new ways of thinking. We're talking about strategies like small language models on the edge. That means running smaller, specialized models right on your phone instead of in the cloud. We've got clever prediction tricks like speculative decoding, which basically lets a small model guess the answer and has a bigger model just check its work. That saves massive amounts of energy. Then there's deep quantization, a way to radically shrink the memory footprint of these models. And, the most revolutionary of all, compute in memory, which completely rethinks the entire relationship between memory and compute. So what
is compute in memory. Well, instead of constantly shuttling data back and forth, what if you perform the calculation right where the data lives? It's a profound paradigm shift. It's like demolishing the highway between the factory and the warehouse and just building the factory inside the warehouse. It attacks the memory well at its absolute source. So, you see, the solution isn't just about building a faster processor. It's about redesigning the entire system. It's about building a smarter, more efficient city of data and logic where every component is closer together, which eliminates the traffic jams that are holding all of this back. So, what does all this mean for the future? Well, once you understand that the core constraint is physics, the entire strategic landscape of AI just changes. You start to see who the real winners might actually be.
The old way of winning was simple. Have the biggest model with the most parameters trained on the most data. But that moat is evaporating. The new, durable competitive advantage, the new moat, is having the most efficient, lowest cost inference stack. It's not about who has the biggest brain anymore. It's about who has the most efficient metabolism. This quote just nails the new reality. The value isn't in the raw model itself anymore. It's in the system that deploys that model cheaply, safely, and effectively within a specific workflow. That is where the lasting power really lies. So, the winners of this next era, they're going to look different. They will be masters of physics and systems architecture. Their advantage won't just be a clever algorithm, but what analysts are starting to call an execution moat, just the sheer operational excellence of running AI at scale for less. And they will treat running AI on your local device not as some novelty, but as an economic and physical necessity. So forget the parameter counts. The real race was never about who could build the biggest model. It's a far more interesting and way more difficult race. Who can master the fundamental physics of computation? The companies that truly understand this, those are the ones built to win not just the next cycle, but the next decade.